Good morning, students. Today onwards, we will study PUC first year inorganic chemistry units, and they are first we will complete chemical bonding molecular structure. There is unit number 15. The remaining 3, 16, 17, 18. There is S block, P block, then hydrogen, redox reactions, environmental pollution. But this is a lengthy topic. First we complete chemical bonding and molecular structure. See what is meant by chemical bond. So consider a compound sodium chloride and hydrogen molecule. NaCl, it is an ionic compound. Hydrogen, it is a covalent molecule. See how there is a bond, formation of bond between the sodium and chlorine. Sodium atom, chlorine atom. Atomic number of sodium 11 and chlorine 17. And outer electrons, valence electron NS1, because sodium 1s2, 2s2, 2p6, 3s1. This is 3s1. Therefore, it has electrons, valence electron only 1, and here 17 NS2 NP5, 1s2, 2s2, 2p6, 10 electron, 3s2 3p5. Therefore, valence electrons are 7. Then sodium, it is an electropositive element. It has tendency to lose completely electron, and hence when it loses electron or transfer electron to other atom, now it will become positively charged. And this electron adds to Cl. There is a chlorine. It is said to be electronegative element. It can attract electron from sodium. Then it will become what? Cl minus. Because 2 plus 2 plus 2 plus 1, 7 plus 1 electron. If electron added negative charge, then electron lost positive charge. Then these two ions combine, and there is some force exists. That is called electrostatic force of attraction, which holds two species or two particles in a molecule. And this type of bond or electrostatic force is said to be ionic bond. This is one of the type of chemical bond. And in case of hydrogen 1s1, 1s1. Valence electron 1, valence electron 1, and these mutually share. There is a mutual sharing of electron between the two atoms in hydrogen molecule. Therefore, there is a formation of what? H. It is a covalent bond. It is these two atoms are by covalent bond. And so now we can define what is meant by chemical bond. The chemical attractive force which holds two constituents, and that constituent may be ion or atom or even molecules in a substance, that is said to be what? Chemical bond. And what is the structure of these? Also we can study structure of inorganic compound and also organic compounds. So they are based on the number of lone pairs and type of hybridization, etc. Now first I will explain about the formation of a ionic bond. Here partially I covered how ionic bond is formed. Then now condition for ionic bond, how this bond is produced. So cation size of the cation should be large. Size of anion should be small. Sodium, potassium, rubidium, cesium, fluorine, chlorine, bromine, iodine. Yes. Cesium chloride, rubidium chloride. See here, size of cation, cesium higher. Therefore, cesium chloride is more ionic than rubidium chloride. Anyway, they are ionic compounds, but which is more ionic, that is depend upon what size of cation. cation size should be large, anion size should be small, and charge on the cation small, and charge on the anion also small. Small charge, then high charge in case of cations, and small size in case of anions. Therefore, sodium fluoride, sodium chloride, potassium fluoride, potassium chloride. Then we can compare which is more ionic. KCl, KF. Small size, high electronegativity, means it depend upon size of the atom, charge of the species, and electronegativity of the atom. If electronegativity is higher, then it is said to be more ionic. So these are the characteristics for ionic compounds. And even electron dot structure also we can write for what ionic compounds and even organic compounds. This is called a Levy's dot structure or electron dot structure. For hydrogen, valence electron, hydrogen or valence electron, and this is said to be electron dot structure for hydrogen molecule. If it is methane, central atom carbon, and having 4 valence electrons. The atom number of carbon is 6, 1s2, 2s2, 2p4. Valence shell 2. Then valence electrons are 6. Therefore, 1 minute for 6. Valence electrons are 4 and valence shell 2. Therefore, only valence shell electron you have to consider, and these are said to be 4 electrons, and all are actually unpaired. Then for methane, this is a methane molecule, and because of mutual sharing up of electron, there is a formation of a covalent bond. But covalent bond formation occur between the two atoms. But that atom should be electronegative. Both should be electronegative element. But in case of ionic bond, one is electropositive element, other is electronegative element. But in case of covalent bond, both must be what? Electronegative elements. May be similar or dissimilar. So carbon, hydrogen, oxygen, nitrogen, hydrogen, oxygen, carbon, sulfur, etc. But in all these cases, there is a formation of what? Covalent bond. Formation of a covalent bond. So what is the main condition for covalent bond? The atoms which are combining atoms, and they must be electronegative. May be similar or dissimilar electronegative. And there is a mutual sharing up of electron between the two electronegative elements, and that can cause formation of covalent bond. This we can study in this topic: ionic bond, covalent bond, hydrogen bond, ionic bond, covalent bond, hydrogen bond, then coordinate bond, next metallic bond, and van der Waals force. Totally 6 types of chemical bonding we can see. 6 types. But in this main important ionic bond and covalent bond. But in detail we can study about the covalent bond. Covalent bond. Then, as I told, a chemical bond formed between the two electronegative atoms. By mutual sharing of electron, that is called covalent bond. And it can have 1, 2, 3 different bonds between hydrogen, 1 bond, oxygen, 2 bonds, nitrogen, 3 bonds. But all these are called covalent bonds. If one valence electron combine each other, they can form a sigma covalent bond, means 1 covalent bond. Then between 2 oxygens, total valence electrons are atom number 8, 1s2, 2s2, 2p4. Yes. 4 plus 2, 6 plus 2, 8. Then out of 8, see here, how many are valence electrons? 2 plus 4. Then here, uh, in p orbital, one is paired electron, and here one more paired electron. Then these are paired electrons. Next, there is a formation of a bond, but total electrons are 6. Out of 6 electrons, 2 are involved in the bonding. Therefore, this is oxygen molecule. And in case of nitrogen, atom number 7 here 3. 3 are unpaired and 1 is lone pair, therefore lone pair. And these 3 unpaired electrons, they can form covalent bond. Means there is formation of a sigma covalent bond and a pi covalent bond. If there is a double bond, one is sigma, other is pi. Triple bond, central one is sigma, below and above pi. Below and above pi bonds. Like this, covalent bonds are formed by mutual sharing up of electrons. And also we can study octet structure. Octet structure. So here, in a molecule, the central atom, in the molecule central atom, or each atoms in a molecule, they should have octet structure. Only in few cases, what doublet structure, like hydrogen. But in case of methane, around carbon, 4 bonds and 1 bond equal to 2 electrons. Therefore, total electrons are 8. Therefore, it is said to be completed octet. 2 plus 2 plus 2 plus 2. It is having completed octet. Next one, BCl3. For chlorine, 3 lone pairs. Two plus 2 plus 2 plus 2, 8. This Cl completed octet, but boron 2 plus 2 plus 2, 6. It is incompleted octet. This is the atom having incomplete octet. In a molecule, there is said to be what? Lewis acid. If it is having a completed octet, then with lone pair, there is called a Lewis base. So, example, ammonia. In case of ammonia, nitrogen carry lone pair with 3 bonded pairs. Total electron 2 plus 2 plus 2, 6 plus 2. 6 plus 2, 8. Total 8 electron, but the central atom contain lone pair. Then it is having what extra electron pair. Here it requires electron pair. Therefore, electron deficient Lewis acid and electron rich is called Lewis base. Therefore, completed octets, if they contain what lone pair of electron in the central atom, then it is said to be Lewis base, or it is said to be what having completed octet. Completed octet, incompleted octet. Then in case of PCl5, see what happens. PCl5, this is PCl5. Right. Then around P you can see 2, 4, 6, 8, 10. It is called expanded octet. In BCl3, incompleted octet, and this one expanded octet. And if it contains 8 electrons, it is called a completed octet. Then completed octet or even expanded, the molecules are said to be stable. Okay, they are said to be stable. Then, based on the valence bond theory proposed by a scientist, Linus Pauling, we can study how chemical bond is formed and even by using orbital structures we can study type of hybridization. Which type of hybridization occur in different atoms in a molecule. So according to Linus Pauling, the combining atoms should have unpaired electron in the what atomic orbital, and if atomic orbitals overlap or if they mix up, then they can form new type of orbitals, and they are said to be hybrid orbitals, and then they are having the same number as in the what original atoms which contain orbitals. Example, hydrogen s orbital 1s1, s orbital 1s1, and they can combine sigma bond. Valence electron they can combine each other to form sigma bond, and is called face-to-face overlapping. Means when the two atomic orbitals hybridize or mix up, they can form new orbital with the same number. Okay, then 1s you get sigma, what covalent bond, sigma covalent bond. Next 1s and 3p, 1s 3p. 1s 3p orbitals overlap and they can form. But p orbital let it is a pz orbital, py or px orbital, px, py, pz. So according to the theory, pz orbitals they are considered to undergo what overlapping along their axis. If overlapping occur along their axis, it can form sigma bond, and if they overlap laterally or sideways, they can form pi bond. Therefore, px can form pi bond, py can form pi bond. Py overlap or px overlap, they can cause formation of a pi bond, but pz overlap can form sigma bond. Okay, so these are simple what theory to form sigma bond and pi bond. So in case of oxygen molecule, yes, there is a pi bond and a sigma bond. But pi bond is formed by the lateral overlapping of px or any one orbital. But sigma bond is always formed by what pz orbitals. Now types of hybridization. You studied about hybridization. sp3, sp2, sp. sp3, sp2, sp. Methane and all alkanes, ethane, propane, butane, pentane. Then acetylene this is a double bonded undergo sp2 hybridization. Alkenes where C double bond C under hybridization, and this is what sp2, and even BCl3 and here BeCl2, sorry, in sp BeCl2, and sp3 water NS3, etc. Different examples we can study. HC triple bond CH. Okay. So in case of sp3, right? In case of sp3 hybridization, okay, 1s and 3p orbitals of carbon. Two s2, 2p2, 2s1, 2p3, 2s1, 2p3. When the electron jump from 2s to 2p, see here, 2s1, 2pz1, 2s2, 2px1, 2py1, 2pz0. If it is 2pz1 here, 2s1, therefore one s orbital and 3 p orbitals combined. They can form sp3 hybrid orbitals. But how many? See, 1, 2, 3, 4. 4 orbital. Hence, 4 sp3 orbitals are formed. And all these we can write like this. Yes, this is structure of sp3 hybridized carbon. And for methane, H atom, spherically symmetrical, because 1s1 spherically symmetrical, and there is a formation of sigma bond with mode angle 109 degree 28 minutes. This is in case of methane. Similarly, in all the alkanes, ethane, propane, butane, pentane, all. But in case of water and ammonia, see what happens. In this case also, there is a formation of a bond like this, sigma bond, and there are two lone pairs. In case of ammonia, one lone pair, and it is pyramidal. This one bent structure, this one tetrahedral. Therefore, geometry of the molecule depend upon number of lone pairs. No lone pair, sp3 hybridized tetrahedral. Two lone pair, sp3 hybridized bent structure, and one lone pair, sp3 hybridized, and it is a what pyramidal structure. It is having a pyramidal structure. Then similarly, sp2, see here, 1s 2p overlap. 1s 2p overlap. They can form sp2, but number 3 sp2. Correct? 3 sp2. So 3 sp2 orbitals, they can form 3 sigma bonds. 1 sigma here, 2 sigma here. And 1 pi bond, this one. Px or py you can say, and they can overlap sideways, they can form pi bond. Sigma bond, pi bond formation. Pi bond formation occur always when what px or py overlap laterally, right? Overlap laterally. Then sigma bond formation occur when orbitals overlap along their axis or face to face overlapping. Along their axis or face to face overlapping. Therefore, hybridized orbitals overlap along their axis. Hybridized orbitals. Unhybridized orbitals like px or py, then px overlap or px s overlap, py s overlap, they can form sigma bond. So I told here sigma bond pi bond formation. In case of ethene or any alkenes where there is a double bond, C double bond C sp2, but in case of BCl3, atom number 5, 1s2, 2s2, 2p1. Okay, in ground state 2s2, 2p1, excited state. See here, one electron shift here, and sp2, this undergo sp2 hybridization, and here no unpaired. Therefore, like this we can show. Chlorine, pz orbital, and boron sp2 orbitals overlap along their axis. Therefore, they can form sigma bonds. BCl3. So type of hybridization, what sp2 hybridization, BCl3. Similarly for what sp hybridization, 1s 1p here. When 1s 1p orbital overlap, they can form sp orbitals. But how many? 2. 2 sp orbitals like this. sp, one carbon atom, but 2 are unhybridized. Therefore, in case of carbon, like this. CH. But here, one carbon structure, another carbon, Right. Sigma bond CH 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 CH. This is sigma bond. Pi bonds and one more pi bond. Pi bond. Pi bond. So in theory you studied like this, but you should have some idea about this. Then only you can understand chemical bonding. But here, acetylene or alkyne molecules undergo sp hybridization, and even BeCl2, 1s2, 2s2, here 2s2 means electron shift in the 2p, 1 sp means BeCl2 undergo sp hybridization, alkynes undergo sp hybridization, BCl3 undergo sp hybridization, but their geometries depend upon the type of hybridization. Yes, sp2 trigonal planar, sp3 tetrahedral, but depend upon lone pair. No lone pair, tetrahedral. One lone pair, trigonal pyramidal or pyramidal structure, and two lone pair, bent structure. Okay, bent structure. Like this, you can study about type of hybridization and different molecular structures. Next. So this is under VBT, valence bond theory and hybridization. Next, MOT, molecular orbital theory. MOT. Okay. So this we can study after a few minutes.